Let's look at hyperbolas in section 8.5. These are the basic equations for the hyperbolas. Oops, let's bring it up. In this one, the hyperbola's main axis, the transverse axis, is parallel to the x-axis because that's the term that's positive. And the negative is what shows this is a hyperbola. That will come out later when you have to figure out from equations whether something is a parabola or a circle or a hyperbola or an ellipse. The hyperbolas have one of the squared terms being negative, like this shows here. So this is what it looks like if it's going to be, if the transverse axis is parallel to the y-axis. Well, let's go through the basics of what makes up a hyperbola, and we'll use one that's parallel to the x-axis. And I've set this up so that here is the center, and like in so many other things with conics, we use h and k for the x value and the y value of the center. And that h is here in the equation, and the k is there. The a is the amount from the center out to one of the vertices. So this here is a vertex. I'll call the first vertex. And that means over here is a second vertex. There are two of them. And we'll use them later on too. Right now all we need to see is the distance from the center to one of the vertices, and that's a distance of 4. That's A. Now here is a distance of 4. I don't care about the numbers right now. What I care about is that that distance is A. If it was out farther at 5 or 6 or 7, it wouldn't matter. It's the axis that is parallel to the x-axis. And this is called, the one that's going this way this time, is the transverse axis. Oops, what I should say is that the one that has A, that one is the transverse axis. The other axis, which has a distance of B from the center out to its endpoint, is the conjugate axis. And in this example, we see that it's longer. There is nothing wrong with it being longer here. This is one of the things that's different between a hyperbola and an ellipse, is that in an ellipse, not only is it positive here, also the A is always larger than the B. Always, 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 every single time. In the hyperbola, it just doesn't matter. It can be larger or it can be smaller. It can even be equal to in a hyperbola. But it does tell you, the A does tell you the transverse axis, half of that. So that's where we get the A and the B from, and this is where we get the center from. Now, as far as drawing the parabola, here's the steps that you have to do. You have to look at the endpoints of the two axes, and you have to draw a little box to get to the corners of them. I guess you don't actually have to draw the box, you just have to identify the corners. So I have a corner here, and I have a corner here, and a corner here, and a corner here where I wrote over, but we can still use it. You have to draw an asymptote, a line through the center and through the corners. So let me draw what I can here. Those asymptotes will help you now with drawing where the hyperbola goes. If you have this one where it's x that's squared, that's x squared is positive and the y squared is negative, that means with the transverse axis is going this way, parallel to the x-axis, and that's where our parabola is. Now you draw it by going from the vertex out and not parallel to, but almost touching, getting close to and hugging the asymptotes. Never actually touching them. That's one thing about asymptotes. Asymptotes cannot be touched by the line that's getting closer to it. They're off limits to it. Okay, so that's where you draw it. This is a very wide open one, and the equation shows that by one of the, if we did the equation, one of the axes is a lot longer than the other one, and that makes it either really wide, or if the transverse axis is a lot longer, then it would be a very narrow type of hyperbola. I also need to talk about the focus points. The focus points are going to be points right past the vertex somewhere. And those focus points, I'll call this one F1 and I'll call this one F2. So focus, the focus points. And the distance for the focus points is C. So from the center, so I'm going to go like this. This distance is C. And for a hyperbola, we can use A, B, and C, any two of them, to get the third one by using this, that A squared plus B squared equals C squared. This is the normal Pythagorean theorem. Unlike what you see in the ellipse, where this would be subtracted because the A is larger than the C in the ellipse. So that's a definite difference here on these. Okay, now, let's look at one other thing, and that's that in doing these things, you have to be able to write the equations of the asymptotes. And we write those in point-slope form, which is y minus y1 equals the slope x minus x1. So in this case, the center is h for the x and k for the y. So we'll put y minus k equals the slope x minus h. We need the slope. Rise over run, something you've heard and used many times, and we can do that because here is one of the lines, and you're going from this center up to here and over to here. 1, 2, 3, 4, 5, 6, 7. So in this case, it's a distance of 7. Oh, wait a minute, that's the distance b. When you go this way, that's 4, but in this example, without really caring about the numbers, that's a distance of a. So this equation has a b over a asymptote. And this equation has a b over negative a asymptote. That means that I can include both of these. Like I can write this, and I can write it again with a negative, or it is acceptable to put plus or minus there. And then that would be the equation of the asymptotes, the equations of it, because it would be both of them, plus and minus there. And we should have minuses there. So the things you have to be able to do is sometimes to derive the equation from when you see an hyperbola. Other times from the equation be able to graph the hyperbola. And sometimes from either the equation or from a graph be able to state where the focus points are, or where the vertices are, or the amounts, the lengths of the transverse axis or the conjugate axis, or be able to write the equations of the asymptotes. So let's look at a couple of problems that you need to be able to do or comfortable with doing. Okay. And the first thing I'm going to look at right now is how to change, we're going to call this part 1. I'm going to call this part 2. And sort of part 3 of this, because in part 2 we are going to change an equation to standard form. So these two types of equations, this is the standard form. And you will sometimes get it in the general form, which is 6y squared minus 4x squared minus 36y minus 8x plus 26 equals 0. All the conics can be written like this and then changed to their real standard form. This is called the general form. So 2, we're going to change this, and in part 3, we're going to graph it. And then we'll do that again. I'm going to do that in 2 or 3 examples here. So here is where completing the square is very vital. I see, first off, I see a positive for the y squared and a negative for the x squared. That negative for one of the squared terms tells us this is a hyperbola. And I'm going to separate these, and I'm going to put the positive one first. And I'm going to separate them by letters. So we'll put, or by variables. We'll put the y's together, leave a little space because we're going to have to complete the square, put the perfect c in there. Negative 4x squared minus 8x for the x's. And I'm immediately going to subtract the constant and bring it to the other side. Or add it. If it had been minus 26, I would have added it. Here I'm going to subtract 26 and bring it over here. So I do these things first and immediately. Now I'm set up to complete the square. Oops, I'm really not set up to complete the square because the y squared has a coefficient and the x squared has a coefficient. We cannot complete the square until we first move out the coefficient and separate it. So that means we have to take out that common factor. Minus, 6 goes into 36 6 times. Notice these two have a common factor not just of 6 but also of y. Do not take out the variable, only the number, because we need this to complete the square for all three terms. Now we'll take a negative 4 from this one, and this is where I have to be really careful. Let's see, 4 goes into 8 twice, because there's a very common error that people will often make at this point, and I just made it on purpose to show you it. I took negative 4 from the x squared, sort of like dividing by negative 4. The negatives cancel when 4 goes into 4 one times. This is one thing. And I need to divide by negative 4 here. And if you don't write this underneath, you might mistake the fact that you have to cancel those out. A negative divided by a negative is a positive. So if I'm going to take negative 4 out of negative 8x by dividing by it, then that means this sign becomes positive and it's not negative. You don't have to write this kind of thing down when you're doing it, but if you have troubles with negatives, you might want to do that just to be safe. I've been doing this a long time, and I still do this often when I'm doing negatives just to be safe. And in this case, to be safe means doing that and making that plus. So it's plus 2x because we're taking out a negative number. Now we can complete the square for both of these. C is equal to b over 2 squared. So I'll get the correct c for this. That's going to be negative 6 over 2 squared, which is negative 3 squared, which is 9. So I'm going to be adding 9 there. So if I'm going to add 9 to that, on the other side I also have to add 9. Here, c is equal to b over 2 squared. In this case, it's 2 over 2 squared, which is 1 squared, which is 1. So I'm going to add 1. And so over here, oh, wait a minute, I'm not adding 1. Over here I could do plus 1, but it's really not just plus 1. Because here is adding 1, it's not really a 1 that I put in here. It's a negative 4 that I put in here times 1. And, oh, it was a plus 9 here, but it really wasn't a plus 9. So wait a minute, I've forgotten something. This is one of the most complicated parts of this. Watch out, because in reality, that's not a 9. That's really a 54 because it's 6 times 9. That's really a 54 that I'm putting in here. Now, it's a 9 inside the parentheses, but if I multiplied it out, it would be a 54. So instead of a 9, I have to do 9 times 6. So I guess I don't really need the plus sign there. So what I really am doing is 54. And here, this is going to be a plus 1 in here, but it's really a negative 4 times a plus 1. So it's really a 1 times a negative 4, and that means it's a negative 4. So instead of writing that, I'm just going to put minus 4 on that side. So I have subtracting 26 and adding 54 and subtracting 4. So let's do that in a moment, because now let's sort of clean this up. Y squared minus 6y plus 9. So there's the 9, but it's really 54, just like that. 6y squared minus 36y plus 54. Minus 4x squared plus 2x plus 1. So that's really minus 4, negative 4x squared, negative 8x, and negative 4. But we're still in the parentheses right now. Equals, well now, negative 26, 54, and negative 4. If I do 54 minus 4, that's 50. And then 50 minus 26 looks like a 24 to me. 50 take away 26 is 24. Well, now at this point, we have these coefficients, this number. Remember that the term, that the equation has a 1 over here. So this is the point where now you make it a 1 by dividing by whatever you get here. And that means you divide on one side, you divide on the other side. If we divide on the other side, we divide it into both of the terms. So 6 goes into 24. Ooh, and let's set these up as squares. The thing I forgot to do for a moment was I should have just right here done that as y minus 3 squared. So let's do that now. And this part becomes x plus 1 squared. Remember that to do those, if you have done the perfect c in here and you have the perfect square now, then that means you only have to take the b and divide it by 2. Half of the b and use the same sign. Half of the b and use the same sign. And if you multiplied this out, you would have y squared minus 6y, because it's twice that, and then plus 9, because it's multiplying negative 3 times negative 3. Same thing over here, twice of that, and then multiplying it. Now, 6 goes into 24 4 times, and 4 goes into 24 6 times. The negative would stay here as overall all that term. And so now we have correctly changed this general form equation into this standard form hyperbola equation. Now let's graph it. This is the form that I want you to be comfortable using. And we'll write this up here. Y minus 3 squared over 4 minus x plus 1 squared over 6 equals 1. So, I'm going to move this up a bit. Coordinates of the center. Well, the center is going to be h and k. H is here. It's going to be the opposite sign of the one with the x. So it's minus 1. And k is the one with the y and its opposite sign. So negative 1 and 3. I'm immediately going to come down here and go to negative 1 and positive 3. Okay. So my next step, I've gotten that here, will be to look at where all the parts of it are. The vertices, well, the vertices are going to be for the transverse axis, and the transverse axis is using A to go along there. Well, the transverse axis is going to be from the one that's positive, so that means that the A is 2. Take the square root of 4. So I'll put it over here and say A is equal to 2. But that is underneath the y squared. The positive one is y squared. That means that the transverse axis will be parallel to the y-axis. So if A is 2, I have to go up and down with it. So I'm going to have one vertex here and one vertex here. And I can now see that those points, let's see, if I go over here, that's negative 1 and 1 and negative 1 and 5. So I'll come up here and I'll do negative 1 and 1 and negative 1 and 5. Count to be sure. 1, 2, 3, 4, 5. Yep. So that's where the points are for the transverse axis. The direction of the transverse axis, then we can say, is vertical. Coordinates of the foci. The foci, or the focus points, will be out here. Well, to do that, we're going to use c squared equals a squared plus b squared. We know what a squared is. We know what b squared is because it's over here. And if b squared equals 6, then b equals the square root of 6. For now, we will leave that. Actually, all we need for the c is we need the square of b. So c squared is equal to 4 plus 6, because that's what a squared is and b squared is. So c squared is equal to 10. C is equal to the square root of 10. Now, if you're allowed to approximate it, you can do that and get the decimal for that, or approximately what the decimal is. Okay, so if you do that in the calculator, you see that the square root of 10 is 3.162277. Well, we want to if we estimate it to 3, we lose a good deal. If we make it 3.16 or 3.2, we can make it 3.2 or 3.26. Well, at that point, you know, I said 2 or 2.6 would be good enough. I think we can go with 3.2 because, and here's why, approximately 3.2, put that there. We can't like figure out where we are here exactly. I mean, when you graph by hand, it's very hard to get the exact point. So if I go 1, 2, 3, and 3.2, that gets me a little further than 3, but I can't tell here if it's 3.2, 3.16 or 3.2. So 3.2 gives me an idea that it's somewhere around here for a focus point. I'm going to write vertex and center and V, little letters in there to help me with that. And then the focus point this way is 1, 2, 3, and a little bit more. Now I can estimate where that is because the x value is still -1 no matter what, because we're going parallel with the y-axis. So I can go for this one, this focus point is just under 0, so it's a negative, and it's negative that 0.2 that we went. So that means that it's -0.2. And going up, whoops, you can't see that, so let me show you what I just wrote. Went up here and I put in -1 for this point, for the x-axis, and the y, it's just into the negatives a little bit, -0.2, and that's the 0.2. We went down 1, 2, 3, and then the 0.2. And up 1, 2, 3, 0.2. And that's 2, 4, 6. So that looks like the y is 6.2 here. That's how you can get the focus points. You figure out, because of a squared and b squared, what c squared is. You may make it a decimal and round it appropriately for what makes sense for the situation. So now we know where the focus points are. The length of the transverse axis, where we're going from the center to the vertex, that's 2, and 2 this way, that's a distance of 4 units. The conjugate axis, well, we know it's square root of 6. Well, how in the world do we figure out the square root of 6? Again, like the focus point, it's appropriate here to make it a decimal so that we can approximate it on the graph. So, square root of 6 is 2.44. Ooh, that 9 would make that a 5. About 2.5 would make sense. 2.4. If this became a 5, that would round it. You really wouldn't round it there, except it makes a lot more sense here just to say 2.5 instead of 2.45. So 2.5 is an appropriate approximation for this type of a thing. Notice I didn't exactly follow rounding rules in that case. I used rounding rules in a way that made sense and then used that to make it even more sensible with 2.5. I used it to help me make a better decision. So that means I want to go 1, 2, and about halfway here. 1, 2, and about halfway here. So now I have the amount of B and the amount of A. Okay, notice in this case the A is smaller. Well, now I want to actually draw. Oops, let's come down here. The length of the conjugate axis then is going to be about double that. So it's going to be approximately 5 units. Now we need the equation of the asymptotes. Well, that'll be a lot easier if we make the asymptotes first. Oops, not what I wanted. Okay, let's get that setting off. I'm sorry. Trying to get the right button to increase the size of this. All right, this is where now we're going to find, if we were to make these a box, only for the purpose of finding these corners. So I come down here, parallel or perpendicular with that line. Okay, and I come down here. Looks like I'll have it here. So now I'm going to have one line that's going through the center this way, and one line going this way, and one line going this way, and one line going this way. So I have going a rise of 2 and a run of about 2.5. Now this is where what I might be better off doing is saying half of square root of 6. But even then I would only get a decimal. So this is where I can make the equation of the asymptote approximately here, I'll use the 2 and 2.5, okay, and 2 and negative 2.5. So I need the center, which is y. Now it was plus 3, so it's minus 3 in point slope form, equals the slope plus or minus 2 over 2.5. We wouldn't normally write it that way, but it's okay in this situation because sometimes we get those kinds of numbers there. And then we're going to do x plus 1 from the center. Oops, can't read it 1. Okay, now that we have the asymptotes and the equations of them, now we can draw the graph. When you look at these, it's a tendency to come over here and do the graph with lines, the curves going this way. I tend to do that a lot, so I have to stop myself almost every time and check and see, did I do the curves going this way, or did I go them this way, and which is the right way to do it. And I sometimes don't catch myself, but now I will. Now I'm thinking about it carefully, and where you do is you go to the vertices. You look at the transverse axis, find the vertices, and that's where the arms of the hyperbola start from. Okay. There you are. Cool. All right. Now that we have that set up, okay, let's look at what we've done, and we've got it all done. First, we started with the general form of the equation, changed it into the standard form, and used that standard form to give us the center and the amount of A and the amount of B, which helped us get the transverse axis and the conjugate axis. Then we could get the asymptotes, and we could graph the hyperbola. So the hyperbola actually looks like this. Those two curves make the hyperbola. Okay. We've completed it. So let's look at doing another one of these. Right? That's one type of an example. Let's look at a second one. Okay. There's another one that's a y squared. Let me see if I can find one that's a x squared y. Now I guess we'll do another one like this because I don't have that. Oh, gee, I got to do it. Hold on a moment. Let me find. Aha, here it is. Okay. So let's look at this one. 20x squared minus 16y squared minus 160x minus 32y minus 16 equals 0. All right, let's work with this one. And we're going to do the same two things as the last one, which were to first write up the equation. Where is that? To write the correct form of the equation, and then second, to graph it. So that's what I'm going to do with these. Let me find it. And so I'm going to call this one 2A, and then the graphing of it 2B. Okay. So here we'll do another 2A type of thing. 2A, and it's the second one we're doing. Well, I see that the x squared is positive and y squared is negative, so I'll put the positive x's first, or the positive first. 20x squared minus 160x. I'll leave some space and come over here to negative 16y squared minus 32y. And I'm going to add the 16 to both sides so that I get it over here. Now I will take out the coefficients from both of these in order to get the x squared and the y squared alone and positive. So here, if I take 20 from both, I get x squared minus 8x. I'll leave a space and get ready to write the c in here. And I'll put minus 16, y squared plus 2y, and is equal to the 16. So here, negative 16 are divided by negative 16, so the negatives make positive. 32 divided by 16 is 2. Now, c is equal to negative 8 over 2 squared. That's negative 4. And negative 4 squared is 16. So I'm going to add 16 here. It's really not 16. It's 20 times 16. So over here, I'm going to be adding 20 times 16. The 16 times the coefficient. Over here, I see that c is equal to 2 over 2 squared. That's 1 squared. That means I'm going to add 1 here. Well, I'm really not adding 1. I'm going to be subtracting 16 times 1. So here, this is really a negative 16, and I'll do it by saying negative 16 times 1. Okay. Well, now let's clean this up. Since that's going to be plus 16 and negative 8, I can make it the perfect square that it is. Here it's negative 16, y plus 1 squared. So half of that with the same sign, half of that with the same sign, equals, well, 20 times 16 is 320. And 16 minus 16, they cancel themselves sort of out here, don't they? So that means we don't have to worry about that anymore. Okay. So now, let's see. We're going to divide by 320. Divide by 320. Okay. 20 goes into 320 16 times. It's minus 4 squared over 16. Minus y plus 1 squared over 20, because 16 goes into 320 20 times, and a 1 over here. There we are. We have our h and our k, and we have our a squared and our b squared. So now we can graph that one as well. X minus 4 squared over 16 minus y plus 1 squared over 20 is equal to 1. The center will be the opposite sign for the x, the opposite sign for the y. Ooh, well now, let's graph it and let's find the vertices by using A and B, and transverse axis and everything. So notice I go to the graphing pretty quickly because that's going to help me. I want to know the vertices. That means I really need to find the transverse axis, and that means I need the amount here. A is going to be square root of 16, that's 4. Oh, for b, we have another one that's not a perfect square. B squared is 20, so b is going to be the square root of 20. Oops, I want to go 50. So I can find the decimal for that. I can also say that that's 2 root 5, because 20 is 4 times 5, and the 4 is a perfect square of 2. So I wouldn't use square root of 20. I'll leave it like this right now. Coordinates of the vertices. Well, I don't need the b for that. What I need is to find which way I'm going. Well, the transverse axis, because we're underneath the positive x right now, means the transverse axis will go horizontal. Ooh, I'll put that next down here. Horizontal. And we're going to go out a distance of 4 both ways, here and here. So that means the vertices are at 0 and negative 1 and 8 and negative 1. 0, negative 1, 8, negative 1. So those are the vertices. Now, 2 times the square root of 5, that's one of those decimal ones. We're going to have to use a decimal to go up there, but that makes more sense than whatever square root of 5 is. So 2 times square root of 5, and I get 4.47. So 4.5, that rounds to very nicely. If I had done it with square root of 20, that would have been just fine too. We'd be getting the same answer. So I'm still going to get that B is approximately 4.5. So let's go up 4.5. 1, 2, 3, 4, and to about there. 1, 2, 3, 4, and about there. And back to here. I'll come back to the foci in a moment, but the length of the transverse axis would be twice the A, so it's 2A, and this is 2B. So this is going to be 8. Well, this is going to be 2 root 5 times 2, so we could either say 4 root 5, or we could say approximately 9 units. Should remember to write units here, too. Okay. 4.5 units. And the asymptotes we can do in a moment. First, let's take care of the foci. A squared plus b squared is equal to c squared. A squared is 16, b squared is 20, So c squared is going to be 32. So c is equal to the square root of 32, okay? And that's 16 times 2, which is 4 root 2. So we can call it square root of 32 or 4 root 2. This we wouldn't call it. We would use that, but we can still use the square root of 32 to get the approximate decimal if we need to, you know. We do need to because we need to find where the focus point is here. So that's approximately 5.656, 5.7. Approximately 5.7. So I go 4, 5, and 0.7 to about here. That was going to be that the x value is negative 1.7. Negative 1.7. And we're still on the y equals negative 1 line. And on the other way, well, we'll put negative 1 for the y. 1, 2, 3, 4, 5.7. So here would be 9, here would be 10, so there's about 0.7. Okay. If I continue the graph out. So that means it would be 8, 9.7. What I did up here was I put the negative 1.7 and negative 1, and the 9.7 and negative 1. All right, so now the only thing left is the equation of the asymptotes, and then to actually graph it. Well, we have enough information here. I can see there's going to be one of the corners here, and if I bring this one up, another corner here, and then these two match about here, so there's a corner there. And then these two match here, so there's a corner there. So I can continue it. So you see, you don't actually have to put the dashed lines around it. It doesn't hurt to. Sometimes, you know, you avoid a mistake perhaps. But just be very, very careful. So those are the asymptotes. So the equation is going to be y plus 1 equals, and I'll put the slope in a moment, x minus 4. And I'm getting that by y minus k from the center and x minus h from the center.